What if the edge of our solar system was not a vague line on a chart, but a real border with a completely different universe waiting on the other side? And what if a machine built before the internet reached that border and revealed that scientists had misunderstood it for decades? Before we go deeper, do me one favor. If space stories that make you feel small in the best possible way are your thing, tap like, subscribe, and share this with one person who still looks up at the night sky and wonders what is out there. For most of us, the solar system feels familiar. We picture the sun in the center, the planets circling around it, maybe a few comets, maybe Pluto if we are feeling nostalgic. It seems neat, it seems mapped, it seems finished. But that picture is incomplete in a very important way because the real edge of the solar system is not where the planets stop. It is where the sun stops being in charge. That sounds simple, but it changes everything. The sun does not only send out light, it sends out matter. Every second, it throws a stream of charged particles into space. The stream is called the solar wind. It races outward in every direction, carrying the sun's magnetic field with it. Over time, that wind creates a gigantic bubble around our entire planetary neighborhood. That bubble is called the Heliosphere. Inside the Heliosphere, the sun still rules the environment. Its particles dominate. Its magnetic influence matters. Its motion shapes the region around every planet, every moon, every asteroid, and every icy rock drifting far beyond Neptune. Earth, Mars, Saturn, Pluto, and the deep frozen darkness beyond them. All still live inside that bubble. But no bubble lasts forever. Far outside the planets, the solar wind begins to weaken. It keeps expanding, but it loses strength as it spreads into a larger and larger volume of space. Eventually, it reaches a point where it can no longer push outward with enough force to hold back what lies beyond. And what lies beyond is not empty space. It is the interstellar medium, the thin but very real material between the stars. It has its own particles, its own pressure, its own magnetic field, its own history, shaped by ancient stellar explosions and the long motion of matter through the galaxy. Where the sun's bubble meets that outside pressure, a border forms. That border is called the Heliopause. If you cross it, you are no longer in the sun's local environment in the same way. You are outside the protective bubble our star built. You are in interstellar space. That is what Voyager 2 did. And that is why this story matters so much. Voyager 2 launched in 1977. Think about that for a second. This spacecraft began its journey when disco was on the radio, when personal computers barely existed, when most of the people watching this video had not been born. It was never designed for internet fame. It was not built for flashy visuals or social media clips. It was built by engineers and scientists who wanted to do something that sounded almost impossible at the time. They wanted to send a machine across the outer solar system and keep listening as long as it could survive. And survive it did. Voyager 2 flew past Jupiter in 1979 and showed us a system full of storms, volcanoes, and violent beauty. It passed Saturn in 1981. Then it did something no other spacecraft has ever repeated. It visited Uranus in 1986 and Neptune in 1989, becoming the only probe in history to explore those planets up close. After that, its grand tour did not really end. It simply changed direction. The planets were behind it. The unknown was ahead. Year after year, Voyager 2 kept moving outward. It crossed distances so huge that normal intuition breaks down. Millions of miles become meaningless. Billions of miles become routine. Signals sent from Earth take many hours to reach it. Signals sent back take many more hours to return. When scientists speak to Voyager 2, they are speaking into the past and waiting for the past to answer. By the time Voyager 2 approached the outer boundary of the Heliosphere, it had already become one of the greatest engineering survivors in human history. Many people assume that once a spacecraft gets old, its scientific value fades, but Voyager 2 became more valuable with time because its destination was not a planet. Its destination was a boundary humanity had never directly measured in full. That point matters because Voyager 1 reached interstellar space first in 2012, but there was a major limitation. Voyager 1 had lost its plasma instrument many years earlier. That meant scientists could still detect important signs of the crossing, but they could not directly measure some of the most important plasma conditions on both sides of the boundary. Voyager 2 still could. That single fact turned an already historic moment into a once-in-a-civilization opportunity. On November 5, 2018, roughly 11 billion miles from Earth, Voyager 2 crossed the Heliopause. In less than a day of travel time, it moved from one physical environment into another. The solar wind dropped away. Galactic cosmic rays rose. The particle conditions changed. The magnetic surroundings shifted. It had crossed the edge of the sun's bubble and entered the matter between the stars. Now here is where the story becomes more than inspiring. Scientists did not just celebrate, they were stunned, because the crossing did not look the way many models said it should look. For years, researchers expected that the outer edge of the heliosphere would be more like a broad transition zone, a blurry mixing region, where the solar wind and interstellar material gradually merged over a long distance. That would make sense if two vast particle systems slowly blended into each other. But what Voyager 2 saw was far sharper. The change happened fast. At the scale of the spacecraft's measurements, the boundary was surprisingly thin. Imagine walking through heavy fog expecting a slow fade from one country into another, only to find a razor-thin gate where the weather, the language, the gravity of the moment all change almost at once. That is closer to what this crossing felt like in scientific terms. This was not just a technical detail. It meant that the basic picture of the heliopause had to be rethought. A thin boundary behaves differently from a wide, blended one. It changes how particles cross, how pressure builds, and how the sun's protective bubble interacts with the galaxy beyond it. And that was only the first surprise. The next shock came from the temperature and character of the plasma outside the heliosphere. The very local interstellar medium near our solar system was not as calm, cold, and uniform as many people imagined. It was hotter than expected. Not wildly hotter in a dramatic movie sense, but enough to force scientists to admit the neighborhood beyond our solar bubble was not matching the clean textbook version. That matters, because when a model misses temperature, it is usually missing part of the physics behind the system. Temperature is not decoration. It is a clue. It tells you about energy, motion, pressure, and the way a region has been shaped by events over time. In other words, Voyager 2 was not just finding numbers, it was exposing assumptions. Then came another discovery, one that reaches all the way back to Earth. Just inside the Heliopause, Voyager 2 detected evidence of a kind of magnetic barrier. This region appears to help block or slow some of the cosmic rays trying to move inward from interstellar space. Cosmic rays are not harmless background noise. They are some of the most energetic particles in the universe, launched by events like supernova explosions and other extreme astrophysical processes. They rip through space at extraordinary speeds. Too many of them reaching the inner solar system would mean a harsher radiation environment for planets, spacecraft, and future human explorers. The heliosphere helps shield us from part of that storm. The outer boundary of the solar system is not just a distant scientific curiosity. It is part of the reason the inner solar system is more protected than it would otherwise be. It is more like a dynamic shield, imperfect but real, shaped by the balance between our star and the galaxy pressing against it. Voyager 2 helped show that this shield may work in ways that were not fully understood before. And then the bigger realization began to form. Voyager 2 was not crossing the same exact region of space that Voyager 1 crossed. The two spacecraft left the solar system in different directions. Voyager 1 crossed in the northern part of the heliosphere. Voyager 2 crossed in the southern part. If the heliosphere were a perfectly smooth and symmetric bubble, their experiences should have looked much more alike. They did not. That difference told scientists something important. The heliosphere is not a clean sphere. It has shape. It has distortion. It is pushed, squeezed, and sculpted by the sun's motion through the galaxy and by the pressure of the interstellar medium outside it. One side may behave differently from another. One region may be stronger, thinner, or more compressed than the next. This is the kind of detail that sounds abstract until you realize what it means. If the shield around our solar system is uneven, then the way cosmic radiation interacts with the solar system may also be uneven. The sky is not just above us. It is pressing on us from all directions, and the structure of our heliosphere changes how much of that pressure gets through. That turns Voyager 2 from a distant explorer into something almost intimate. It is helping explain the invisible conditions that shape the environment in which Earth has existed for billions of years. And it gets even more serious. When scientists compared the data from both Voyagers, they found signs that the interstellar magnetic field outside the heliosphere was stronger than many earlier models expected. That means the galaxy is pressing against our solar bubble harder than we thought. Some studies based on the crossing suggested that the external pressure from particles and magnetic fields could be far greater than older estimates had assumed. That does not mean Earth is suddenly in danger, but it does mean the heliosphere may be more compressed, more dynamic, and more dependent on outside conditions than we once believed. Here is why that matters over the long term. Our sun is moving through the galaxy. It does not sit still in a timeless void. Over immense stretches of time, it passes through different interstellar regions, and those regions can vary in density, magnetic activity, and pressure. If the sun enters a tougher neighborhood, the heliosphere could shrink. If it shrinks, the inner solar system might receive more cosmic radiation than it does now. That is not a science fiction guess. It is a real scientific question about how the galactic environment may influence the protective bubble around our star over geological timescales. So yes, Voyager 2 crossed a distant border, but what it found speaks directly to the stability of the shield around the place we call home. Quick pause before we go deeper. If this story is already changing how you think about space, hit subscribe now, leave a comment with the word Voyager, and send this video to the friend who loves the idea that the biggest discoveries often come from the oldest machines. One of the most beautiful things about this mission is how deeply human it feels. Not because Voyager 2 has emotions. It does not. Not because space is romantic by itself. It is often cold, violent, and brutally indifferent. But because this mission is what human patience looks like when turned into hardware. Think about the people who launched Voyager 2. Many of them knew they would never see the end of the mission. They still built it. They still tested it. They still trusted that decades later someone else would be there to receive its signals and understand what they meant. And that is exactly what happened. A spacecraft created in one era answered a question in another. That kind of continuity is rare. It is easy to get used to instant results. We live in a world of updates, refresh buttons, overnight reactions, and constant noise. Voyager 2 belongs to a slower form of ambition. It is a reminder that some of the most meaningful human achievements unfold across generations. The spacecraft itself is aging. Its power comes from radioactive decay, and every year it loses a little more energy. Engineers have had to make painful choices about which systems to keep on and which to shut down so the mission can continue as long as possible. Each remaining instrument is precious. Each watt matters. That creates a strange emotional tension around every new update from Voyager 2. On one hand, it is still working, still sending data, still moving farther into interstellar space, deeper into a region no spacecraft from Earth had directly sampled before it arrived. On the other hand, the clock is always ticking. We know this mission is finite. One day the power will run too low. One day the voice from that distance will fade for the last time. And when that happens, the map stops wherever it stops. That is another reason the 2018 crossing was so important. No replacement is currently following Voyager 2 on the same path, with the same ability to take direct plasma measurements there. We do not have a backup explorer about to arrive. We do not have another machine ready to cross the same border next year and fill in the missing pieces. Voyager 2 is not just valuable. It is singular. Now imagine the scene from Earth. Scientists are watching streams of data from a machine older than many of them are. That machine is more than 11 billion miles away. It is operating in deep cold. It is surviving on shrinking power. And then it sends home evidence that a major scientific boundary is sharper, hotter, and more complex than expected. That is the kind of moment science lives for. Not because it proves humans were smart, but because it proves humans were humble enough to be corrected by reality. That may be the deepest lesson in the whole Voyager story. We often talk about science like it is a collection of facts. But science, at its best, is a process of letting the universe say no. No, the boundary is not as broad as you thought. No, the external medium is not as quiet as you imagined. No, the heliosphere is not perfectly symmetric. No, your neat diagram is not the full truth. Voyager 2 did not arrive with opinions. It arrived with measurements. And measurements have a way of stripping away ego. This is also why multiple research papers were published together after the crossing. Scientists from different instrument teams knew the story only made sense as a whole. Plasma data meant more beside magnetic data. Particle counts meant more beside the structure of the boundary. Together, they revealed a system more dynamic than expected. This was not just another data point in a giant archive. It was a map correction at the edge of the solar system. And what a correction it was. The old image many people had in mind was simple. The sun creates a broad bubble. That bubble gradually fades into interstellar space. Outside is a quiet background. Inside is the familiar solar environment. Nice and smooth. Voyager 2 replaced that image with something far more alive. A thin border, strong outside pressure, hotter local interstellar plasma, a magnetic barrier, an asymmetric heliosphere, a connection between the farthest reaches of the sun's influence and the radiation conditions much closer to Earth. That is not less beautiful than the older picture. It is more beautiful because it is more real. And reality almost always has sharper edges than our first guesses. There's another layer to this story that makes it unforgettable. Voyager 2 is not heading toward a destination in the normal sense. It is not going to orbit another world. It is not aiming to land. It is not searching for a dramatic final image. It is drifting outward, steadily, into a region so vast that even calling it a region feels too small. Its path through interstellar space is not a sprint toward an ending. It is a long act of listening. That makes the mission feel almost poetic. But the science stays brutally concrete. The spacecraft continues to sample magnetic fields, particles, and plasma conditions as it travels farther from the heliopause. Every reading adds context. Every day of function extends the first direct profile of our local interstellar environment. And that phrase matters. Local interstellar environment, not a distant galaxy, not a hypothetical cloud light years away. The actual environment surrounding our solar system right now, Voyager 2 is telling us what our cosmic shoreline is like. If Earth is a house, then Voyager 2 has gone beyond the yard, past the fence, out to the road, and into the dark field beyond the property line. It has turned around, not physically, but scientifically, and told us something astonishing. The world outside is not what you drew on the map. Second stop before we reach the final stretch. If you want more videos that turn real science into stories you can actually feel, tap the like button, subscribe for the next deep dive, and share this video with someone who thinks old missions cannot still change modern science. Now let's talk about the emotional weight of that invisible line Voyager 2 crossed. Humans love visible frontiers, shores, mountains, gates, horizons. But the Heliopause cannot be seen with your eyes. There is no glowing wall, no cosmic signpost, no grand finish line hanging in the dark. It is made of changing pressures, particle behavior, magnetic structure, and plasma conditions. And yet, it may be one of the most meaningful borders our species has ever crossed. Why? Because it marks the edge of the environment built by our star. Everything in human history happened inside that bubble. Every city ever built, every language ever spoken, every war, every love story, every child looking up at the sky, every telescope, every idea about where we are in the cosmos. All of it happened inside a region still shaped by the sun. Voyager 2 went beyond that. Not beyond the reach of sunlight entirely, because sunlight goes on forever, growing weaker with distance, but beyond the region where the sun's wind and magnetic influence still dominate the local space environment. Beyond the home field. It is difficult to overstate the symbolic power of that. Humans did not go with it physically, but something human absolutely crossed with it. Curiosity did, craft did, long-term thinking did, our refusal to stop asking what lies farther out did. And then, on the other side, reality answered in a way nobody fully expected. That is the emotional core of the story. Not that Voyager 2 crossed the edge, but that the edge answered back. It told us the boundary is sharper than expected. It told us the nearby interstellar medium is more active than expected. It told us the sun's protective bubble is shaped less like a perfect sphere and more like a pressured, uneven structure in constant negotiation with the galaxy. And hidden inside all of that was a quiet truth that feels bigger than physics. Home is not isolated. Our solar system is not sealed off from the Milky Way like a glass case. It is exposed, pressed on, influenced, and partly protected in ways that depend on a living interaction with the larger galaxy. We are inside a bubble, yes, but the bubble is not permanent, not rigid, and not simple. That should not make us feel unsafe. If anything, it should make us feel connected. The galaxy is not a backdrop. It is part of our story. Voyager 2 proved that in the most direct way possible, there is also a strange dignity in the fact that this discovery came from an old spacecraft, not a shiny new flagship mission. Voyager 2 reminds us that endurance can be revolutionary. The mission kept going long enough to reach the question nobody else could yet answer. That happened because engineers built carefully, operators adapted constantly, and scientists kept paying attention decade after decade. This is what it looks like when civilization invests in knowledge that outlives trends. It is about what becomes possible when people commit to something that may take 40 years to matter. Most of us will never build a spacecraft or analyze plasma beyond the Heliopause, but we all understand the difference between chasing what is immediate and building something that can keep speaking long after launch. Voyager 2 is a lesson in delayed meaning. You send something out, you care for it, you keep the connection alive, and one day, far beyond where anyone expected, it tells you something that changes the map. So when people say Voyager 2 crossed the edge of the solar system, do not picture a dramatic finish line and then silence. Picture a passage into a harder, stranger truth. Picture the sun's influence ending in a thin and beautiful tension between inside and outside. Picture the galaxy pressing against our star's great bubble. Picture an old machine, surviving long enough to reveal that the border of home is not where we thought it was, not shaped how we imagined, and not as simple as the old diagrams made it seem. And then picture this. Right now, as you listen to these words, Voyager 2 is still out there, still moving, still aging, still carrying instruments through interstellar space, still sending back whispers across billions of miles. Those whispers are slow, faint, fragile, but they are real. And inside them is one of the most powerful messages any mission has ever delivered. The unknown is not empty. The edge is not simple. And the universe is still capable of surprising us, even with a spacecraft old enough to belong in a museum. That may be the most inspiring part of all. Not just that we built something durable or that it survived, but that it kept going long enough for reality to reward our patience. One thin boundary in the dark, one crossing, one set of measurements. And suddenly the outer edge of the solar system was not a vague idea anymore. It became a physical place with structure, pressure, temperature, and consequence. A place that helps shape the radiation shield around Earth. A place where the sun meets the galaxy. A place we had guessed at for decades and only truly began to understand when Voyager 2 arrived. So the next time someone says space is empty, remember this story. Empty space pushed back. Empty space had heat, pressure, and magnetism. Empty space drew a line against the solar wind and forced us to redraw the map of our own cosmic neighborhood. And a machine launched in 1977 was the one that showed us. If that does not make you feel wonder, I do not know what will. Because somewhere beyond the planets, beyond the Kuiper Belt, beyond the comfort of familiar names, beyond the bubble of the sun itself, a human-made explorer crossed into the dark between the stars and found that the dark was alive with structure. That is not just a scientific discovery, it is a reminder. There is always more beyond the edge. And when we are brave enough, patient enough, and curious enough to cross it, the universe does not stay silent. It answers.